Analysis, Chapter 9, Section 5, Complex Numbers. I'm your host, Dr. D. Okay, let's get started. Complex numbers, we're going to be studying these for the rest of the chapter. And this section, you've basically had most of this stuff in Algebra 2 and Math Analysis, so it should be pretty simple. So let's just start with the imaginary root I, which you all know equals the square root of -1. So if I square the square root of -1, I just get -1. Now, if I cube the square root of -1, then that's going to really be I squared times I, which is -1 times I, which is just -I. Okay, now, if I take I to the fourth, that's going to be I squared times I squared, which is going to equal -1 times -1, which equals 1. Now, if I go I to the fifth, I'm going to just start this cycle all over again. So I to the fifth is going to equal I to the fourth times I. And remember, I to the fourth is 1. So I to the fifth just equals I. I to the sixth equals I to the fourth times I squared, which equals 1 times -1, which equals -1. Then I to the seventh is I to the fourth times I cubed, which is 1 times -I. So I to the seventh is going to be -I. And then I to the eighth is going to equal I to the fourth times I to the fourth, which is 1 times 1, which is 1. And if we go I to the ninth, then we're back to I. And so basically then what we could say is I to the 4n, I to any multiple of 4 is going to be 1. I to any multiple of 4 plus 1, 1 past a multiple of 4. Well, what is 1 past a multiple of 4? It would be 5 or 9 or 13 or 17 or 21. Those I values are going to be I. Then I to the 4n plus 2 is going to be -1. Now, 4n plus 2, that's going to be 6 or 10 or 14 or 18, all those, -1. Then I to the 4n plus 3 is going to be -I. That would be I cubed, or I to the 7th, or I to the 11th, I to the 15th, 3 past multiples of 4. And then I to the 4n plus 4 is back to I to the 4n, which equals 1. So, what that means is I could tell the value of I to any power. So, let's try a couple examples. If I want to know I to the 153 power, well, I just need to find out what the remainder of 4 is of 153. So just go 153 divided by 4. 4 goes in 15 3 times, so I've got 12. 3 left over, bring down the 3, and then there's an 8 minus 32 is 1 left over. Now, I don't care about the 38, because that's basically I to the 4th to the 38th, which is 1 to the 38th, which is just 1. But what I do care about is there's 1 left over. So that makes this I to the 1st, which is I. Okay, so then I could say that I to the 154th, well, that's going to be a remainder of 2, so that becomes I squared, which is -1. And I to the 155th is I cubed, remainder of 3, so that's negative I, and I to the 156, 156 is a multiple of 4, so I to the 156 would just be 1. Okay, now let's crank up the juice just a bit. What we're going to do is we're going to talk about I to negative powers. Ooh, yeah, it just gives you a little tingle thinking about that. Okay. Now, what about I to the negative 7 power? Okay, now, what I like to do is just add the smallest multiple of 4 that's going to get me up over 0 into the positives. So I could say I to the negative 7th equals I to the negative 7th times I to the 8th. Because remember, I to the 8th is 1. So when I'm multiplying by I to the 8th, I'm just multiplying by 1. So this equals I, and that's it, game over. Okay, now what about I to the negative 23rd? Now let's make it, I just made the same thing. Let's make it I to the negative 25th. Okay, I to the negative 25th. Now, I need to add some, get rid of that thing. I need to add some I to a power. I need to add something to negative 25 to get it positive, and it's got to be a multiple of 4. Now, I don't want to make it too big a multiple of 4, so I'm just going to say, what's the smallest multiple of 4 that I can get a positive? And that's going to be I to the 28th. So this ends up being negative I. Okay, so let's try I to the negative 375. So I to the negative 375, well, what I want to do is just divide 375 by 4, and I end up with, oops, make that a 9. 9 minus 36 is 1, 15, 3 left over. So remainder of 3. So 93 with a remainder of 3. So basically, if I multiply this by I to the 376, then 376 has a remainder of 4, or remainder of 0. So that means this equals just plain I. So now there are a couple other methods in the book if you want to check them out. Page 580. I kind of like this method. Just find out what the remainder is and get the nearest remainder of 4 that's above it. And then you're just going 376 minus 375 is 1, and that's it, you have I. Okay, so next thing, we're going to be simplifying complex numbers. Addition, subtraction, multiplication, division. So let's try that. So I've got 5 plus 3i plus 2 minus 6i. There's two complex numbers added. Well, I've got real and imaginary. I cannot add the imaginary with a real or vice versa. So all I do is keep the real added to the real and the imaginary to the imaginary. So I have 5 plus 2 is 7, and 3 minus 6 is minus 3i. That's it, game over. Now, if I've got 5 plus 3i minus 2 minus 6i, this is pretty tough. There's a minus outside the parentheses. What shall we do? Oh, the laugh's too low here. Okay. Okay. 5 minus 2 is 3. And 3i minus negative 6i is 9i. That's it. Okay, so next we're going to tackle multiplication of complex numbers. So 5 plus 3i times 2 minus 6i. Okay, so this is basically distribution, or back in Algebra 1 we called it foiling. But 5 times 2 is 10 minus 30i plus 6i minus 18i squared. Now, you remember that I squared is negative 1, so this is basically 10 minus 24i plus 18, because it's a minus 18 times negative 1. So 10 plus 18 is 28 minus 24i. That's it, game over. Okay, and now it's time for division. So if we go 5 plus 3i divided by 2 minus 6i. Now, the point here is we can't have I in the denominator. Now, if we just multiply by I over I, we're still going to have I in the denominator. So the only way to get rid of the I in the denominator is to multiply by the conjugate. So we've got 2 plus 6i over 2 plus 6i. Always multiply by the conjugate of the denominator. So now what we end up with is, on the bottom, we've got an a minus b times a plus b, which gives us a squared minus b squared. And on the top, we just FOIL it, just like we did before. So we've got 10 plus 30i plus 6i and plus 18i squared. Okay, so the bottom ends up being 4 minus a negative 36, which is 40. And the top ends up being 10 minus 18, which is negative 8i, or I'm sorry, negative 8, and then plus 36i. Now, the next thing we can do is 8, 36, 40. There's a 4 in everything here. So we can make this negative 2 plus 9i all divided by 10. Now, you'll see some textbooks that will leave it like this. But this is really unacceptable, because what we have here is a combination of real and imaginary, and they don't go together. So all complex numbers have to be written in the form a plus bi. A plus bi, or a minus bi. So all we do is we're going to split this up into negative 2/10 plus 9/10 I. So there's our a plus bi. So this is it, game over. All right, the last thing is we're going to be doing the iterations, and that ends up being really simple too. So, okay, so if we have f of z equals, now let's just make up something else, 1 plus I times z. Now, z sub o is going to be 1 plus I, and then z sub 1 is going to be f of z sub o, and z sub 2 is f of z sub 1, and z sub 3 is f of z sub 2, and it just keeps going. So we could say z sub anything is going to equal f of z from the one before it. Okay, so I know z sub o is 1 plus I, so z sub 1 is going to be 1 plus I times 1 plus I. All I did was I plugged in my z sub o for z. So 1 plus I quantity squared. Now I could FOIL this if I had a mediocre Algebra 2 teacher that didn't teach me any patterns. But you guys, I happen to know, had a phenomenal Algebra 2 teacher. At least most of you. At least most of you. All right, so we just go a plus b times a plus b, a squared plus 2ab plus b squared. Now we've got 1 minus 1 is 0, so we end up with 2i. So z sub 1 is 2i. Now z sub 2 is going to be f of z sub 1, which is going to be 1 plus I times 2i. So I distribute that, and I end up with 2i plus 2i squared, which equals negative 2 plus 2i. Okay, now I go to z sub 3, which equals negative 2 plus 2i times 1 plus I, which equals negative 2 minus 2i plus 2i, so the 2i's are gone, plus 2i squared, which equals negative 2 minus 2, which is negative 4. That is right. Okay, so now I can say z sub 4 equals 1 plus I times negative 4, which equals negative 4 minus 4i. And then z sub 5 is going to equal negative 4 minus 4i times 1 plus I, which is going to equal negative 4 minus 4i minus another 4i is negative 4 minus 8i minus 4i squared, which is going to be plus 4, which is going to equal negative 8i. Okay, so we could keep going, but you're going to end up seeing a pattern here that you could find out any z value. And if you remember back to Algebra 2, this is the Mandelbrot set when you end up with a larger and larger value, then it's not part of the Mandelbrot set. But if you end up with something that ends up cycling around, then it is part of the Mandelbrot set. So this, you can see, is going to increase indefinitely, but it's increasing with a pattern. So that's basically it. Have fun with these. Okay.